So our last section of chapter 4, section 4.3, combines the modeling or building of functions that we did at the end of chapter 3 from section 3.6 with the properties of quadratic functions from our last section 4.3. So this is section 4.4. Sorry about that. So gentle reminder that our parabolas, whether they open up or down, will have a vertex, and that vertex is either the minimum if it opens up or the maximum if it opens down. And we can find that vertex by using the formula of negative b over 2a and then taking that x coordinate, plugging it back into the function. Because what we're going to be doing is building a quadratic function, then we're going to find its maximum or minimum. So these are my favorite problems in the whole course. So example 1 tells us that a farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on a straight highway. If the farmer does not fence the side along the highway, what's the largest area that can be enclosed? So what we're going to do first is go ahead and draw a picture in order to get a handle on what's going on. So here's my highway. Here's my rectangular plot. And we want to fence in that rectangular plot. So let's give it some dimensions. I like to use L and W. So L for length and W for width. The problem is asking us to find the largest area. So we want the maximum area. Well, we know that the area of a rectangle is its length times its width. The problem is as a function that has two variables in it. We need to get rid of one of these. So we need to eliminate one variable. It doesn't matter which one, but we need to get rid of one. And once we do that, we'll actually end up with our quadratic that we need in order to have the max and minimum. Well, how are we going to get rid of one of those? Well, we didn't use the fact that we know how much fencing we have. Well, we have 2,000 meters of fencing. Well, that 2,000 meters, not put the meters in there because that generally confuses people, has to cover how many lengths and how many widths. So again, I'm leaving that alone for a minute. I'm going to come back over here and talk about the actual fencing. Well, when I fence this in, I'm going to use this width once on this side and once on this side. So I'll have two widths and I'll have one length. So that 2,000 meters has to cover this three sides of our rectangle. So now, because we know we're going to substitute into here, we need to solve this for one of them. And it's easiest to solve for L. So we'll just move the 2W over. So 2,000 minus 2W is equal to L. And now we can substitute. So A is equal to that L, which was 2,000 minus 2W. And we're going to multiply that by the extra W. So all we did was replace L. And now we have a function in terms of W. Let's distribute that W in. I'm going to go ahead and rearrange it into descending order while I'm doing it. So negative 2W squared plus 2,000W. And the reason to do that is we now recognize that this is a parabola. It's opening down and it has a maximum. Now, we don't need to graph it, but if we were going to graph it, then this side would be the input value, which is the width of a rectangle. This vertical axis is the output value, which would be the area. So when we're all said and done, our vertex is going to give me the width and the area, and we need the maximum area, so that'll be our answer. So let's go do our negative b over 2a. So that would be a negative of 2,000 all over 2 times negative 2. So that's 2,000 divided by 4, which is 500. Notice the negatives cancel out again. And what is that 500? Well, according to our little analysis over here, this is the width. So we know that the width of this rectangle is going to be 500 meters. Now they're asking us to find the area. We need the largest area. So we'll take that 500 and put it back to the function. So we're going to find A of 500. So negative 2 times 500 squared plus 2,000 times 500 comes out to be 500,000 meters squared. And that's our maximum area. And that's your first formula in the fence problem. So let's do another one with a slight variation or twist to it. You open any college algebra book or even pre-calculus book, you will find these, or even calculus book, what am I saying? You'll find these problems, the farmer and the fence problems in that. So I'm gonna leave my little picture there for just another example or two. Example 2 reads, a farmer has 1,000 feet of fencing to create a rectangular pen for his cows and then divide the pen into 3 smaller equal-sized pens. What's the total area he can enclose? Yeah, well, it's a rectangle again, no highway this time, so we need all 4 sides on it. But then we're going to come in and divide it in the inside into 3 pens. And because we want to have the largest area, we want to use the smallest runs of fencing. So instead of dividing it this way, we're going to come in and divide it this way. This just makes more sense. We'll get more fencing in a larger area. Again, I'm going to call this side the length. Now it's the entire length, not the individual pens. And this side is the width. Again, we're trying to maximize the area. So to maximize, I can spell area, which is our length times our width. Same issue we had last time. We've got 2 variables as a function. That's no good. So we need to get rid of one of those letters, one of those variables. So we'll come back over here for a minute, leave that area function alone. We're going to work off of that 2,000 feet. Oh, no, sorry, 1,000 feet. Too many numbers floating around in my head. So 1,000 feet of fencing. Okay, so what you need to decide is how many L's and how many W's we need with that 1,000 feet. Well, if you take a look at this, the L's, we have one on the bottom, one on the top. That's 2 L's. So we need 2 lengths. What about the widths? Well, there's 1, 2, 3, 4. So 4 widths. The question becomes, what is it easiest to solve for? Would you rather divide by 2 or would you rather divide by 4? I would rather divide by 2. So I'm going to solve for L because it's the quickest one to solve for. I could have gone for the other letter. It does not matter. So we move over the 4W and then we're going to divide everything by 2. Get L is equal to 500 minus 2W. And then we're going to substitute over here. So we'll write an area function in terms of width. That's going to be our length, which we now know is 500 minus 2W. Now we're going to multiply that by the extra W that's at the end of this. So all we did was substitute in for L. Again, putting it in descending order, that's negative 2W squared plus 500W. And that's our quadratic function. We'll notice that again that it opens down. Once we're done with it, we know that the input value, the x coordinate, the horizontal axis is our width. The output value or vertical axis is the area. Again, W is going to go here. The area is going to go here. We'll do our negative B over 2A. That's going to be negative 500 all over 2 times negative 2. The negatives again will cancel. 500 divided by 4 is 125. And I think we're this time. Yeah. So we found the area. They didn't ask for it, but note you could find the length. So instead of asking you for the maximum area, if they'd asked for the dimensions, you could find them because you know the length is 500 minus 2 times that. But this problem again is asking for area. So we're going to find the area at 125 feet. So that would be a negative 2 times the 125 squared plus the 500 times 125. If you do that, you end up with 31,250 square feet. And there it is. There's our maximum area. So those are 2 different types of the farmer and the fence problem.